Welcome back in another of the OMG is Core Chemistry series, and today we are talking about groups in the periodic table. So to get us started, first off we're going to talk about group 1. So group 1, also known as the alkali metals, they will turn purple on a universal indicator, indicating that they are alkali. Very reactive with water, they form metal hydroxide. So when you add lithium to water, it forms lithium hydroxide and hydrogen. Hydrogen gas then you can identify with the squeaky pop. Okay, pH above 7 because alkalis are anything above 7, acids are below 7. Tarnish in air, so when you put them in the air they react with oxygen to form oxides of them, but as soon as they're in the air they will tarnish, they won't look clean cut or shiny anymore. They're low density, they're the only metals that will float in water, can be easily cut, again that's an unusual property of a metal. Low melting points, again a weird property of metals. Easy to combust, okay, so easy to add to oxygen or to fire to burn. Group 1 metal elements increase as you go down the group. Reactivity increases as you go down the group. The atom gets larger, the outer electron gets further away from the nucleus. The attraction between the nucleus and the outer electron gets weaker, so the electron is lost more easily. So further down the group, they are more reactive. That means that their melting and boiling points get higher as well. Because they're more reactive, it's harder to melt or boil them. Next one then, group 7. Group 7, also known as the halogens, they naturally exist in pairs. So that means that they'll go around like Cl2, I2, so they naturally exist in pairs, and that's known as diatomic. Halogens, again, have low melting and boiling points. The halogens become darker as you go down the group. They get less reactive down the group, okay? So melting and boiling points get lower. Fluorine is the most reactive. This can be seen during a displacement reaction with iron wall. So you've got iron chloride, so iron bound to something. Iron chloride plus fluorine, you would make iron fluoride plus chlorine. So it will displace, it will take the iron away. I should say iron, sorry. Iron chloride plus fluorine makes iron fluoride plus chlorine. That's a displacement reaction because the fluoride steals the iron from the chloride. That's what's going on there. More reactive halogen will displace the less reactive halogen. Elements only need to gain one electron to get full outer shell because they're in group 7. The more shells between the nucleus and the outer electron, the greater the force of attraction between the nucleus and the outer electron. It becomes harder to gain an electron. Okay, you might be asked certain properties of them. Okay, so chlorine is a yellow-green gas. Its property is toxic, it kills bacteria. We use it to sterilise water, which we've learned before. Bromide then, or bromine, red brown liquid, toxic, kills bacteria, a use is not required. Iodine is a grey solid at room temperature. Again, toxic, kills bacteria, it's an antiseptic used in hospital procedures. So when chlorine is on its own, it is chlorine. When it's bound to something else, such as iron, it's iron chloride, okay? So when it's in a compound, the letter changes, so be careful of that. It happens for all of them, but just an example is a chlorine on its own, chlorine. If it's bound to something else, it's a chloride. And then finally, group 0. Group 0 are known as the noble gases. They have full outer shells, also known as group 8 sometimes. Full outer shells, which mean they are already stable, so do not need to lose or gain electrons. They're chemically inert, which means they're unreactive. Non-metals, they're colourless and they exist as single atoms, so they're on their own, monotonic. You have to know the uses of helium, party balloons, war, weather balloons, airships, neon, neon signs, lasers, and then argon, shielding for welding, surrounding the filament in old-fashioned light bulbs. So, as before, pause the video, have a go at the questions, and then the answers will appear to help you. So, what are the elements in group 1 known as? They're known as the alkali metals. What colour will they go on a universal indicator? Purple. They've got a pH of about 11 to 12. What is the equation for potassium reacts with the air? The air is reacting with the oxygen in the air. So it is, let's do it up here, potassium plus oxygen makes potassium oxide. What happens to the elements as you go down the group? They get more reactive. Okay, the reason they get more reactive is there's less of an attraction between the nucleus and the outer shell. So the more shells you've got, there's less of an attraction. So it's easier to lose that final electron, making it more reactive. What are the elements in group 7 known as? They're known as the halogens. What happens? They get less reactive. Because they've got 7 in their outer shell. They've got 7 in their outer shell. And they need to gain 1 more. So the further away you are from the nucleus, so every time you go down the group you add an extra shell, so the further away you are, less of a pull, so it's harder for that final electron to be attracted to the nucleus. What's the use of iodine? Iodine is toxic, and it's used as an antiseptic in hospitals. Why are noble gases chemically unit? They've got full outer shell. It's used in light bulbs. Used in lights. Okay, if you got them all right, move on, watch the next video. If you didn't, go back, start again. Rewatch the video, try and answer the questions until it's all in your head and you're getting really good at answering these questions.